I love to present Alessandro Posato.
Thank you for your invitation, and thank you everybody for being here.
We're going to talk about another technology beside the NDLF, QMR technology, I believe so. In recent years, regenerative medicine has progressively moved towards increasingly integrated approaches where biology, engineering, and energy-based technology are beginning to converge. In this evolving scientific landscape, QMR, which is presented for quantum molecular resonance, represents one of the most innovative and discussed technologies in translational regenerative medicine. You agree, of course. To better understand scientific foundations, technological evaluation, and research behind this platform, we are pleased to welcome Alessandro Posato, Technical Director of R&D and Tela Medical. Welcome.
Thanks to you.
So if you want to present a little bit of and talk about a little bit of yourself.
Yeah.
Okay.
I can start explaining about myself. I'm the R&D Director in Tela Medical. I work in the company for already 13 years. And I'm developing the devices and the technology. And today we're talking about this QMR technology that is absolutely powerful, you will see in the questions.
We are all excited. From a bioengineering perspective, what differentiates QMR technology from traditional energy-based systems currently used in medicine?
Yeah. QMR technology is based on a unique and patented resonance principle. Thanks to the resonance principle, we can transfer the energy from the generator to the biological tissue with a very high efficiency. And high efficiency, or in other words, we can say very low losses, it means that we can obtain what we want, like the cut, the coagulation, or the stimulation of the cells, with a very, very high efficiency and a very low heat.
So one of the most interesting concepts behind QMR technology is tissue preservation without thermal damage, as you already said. Why is this aspect becoming increasingly important in regenerative and functional medicine?
Yeah, thermal damage is absolutely a hot topic in both surgery and in the growing field of regenerative and longevity. In surgical application, devices that are using thermal energy, they face different problems. For example, it's hard to operate in very delicate tissue like the brain, or for the patient, there is a prolonged recovery or the use or abuse of drugs. And in the longevity or regeneration also, the thermal damage is very problematic because thermal damage is creating inflammation. And of course, inflammation is problematic because the tissue is changing. It's becoming fibrotic, and is what we don't want. And that's the reason where we can use our technology.
Perfect. What have been the most interesting findings emerging from current research?
I would say cell genesis. Cell genesis is, I think, the most important part of the true regeneration. When we apply our technology, we are not stimulating the cells that are already existing, that maybe could be damaged or could be inflamed, but we are stimulating the mesenchymal stem cell. Mesenchymal stem cells, of course, is creating a new cell with a new vitality that is then changing and substituting the damaged cell with a new cell, with the morphology and functional that the tissue that it was before.
How important could these mechanisms become in the future of the regenerative medicine?
Yeah, we have to understand that the medicine, the now medicine, is shifting towards the concept of prevention and longevity. And in order to have prevention and longevity, we need to understand how our body is reacting. Our body usually is every day in a constant fight between inflammation and anti-inflammation, degeneration and regeneration. Our immune system is fighting every day. We can, of course, keep this balance with a healthy lifestyle, sports, mental activities, healthy food. But the problem is that when there is this imbalance, we need to act immediately, to be anti-inflammatory in the status, to recover the environment, and to regenerate the cells that are damaged or lost.
QMR technology today is being explored across multiple clinical areas, including rehabilitation, pelvic medicine, surgery, ophthalmology, and also orthopedics. How important is transitional medicine in the evaluation of this technology?
Yeah, absolutely. I would say that fundamental research and development is really important for us to create new technology and new devices. But the basic research, for example, the study that we have on macrophages, the study that we have on mesenchymal stem cells, on senescence, for example, will be just scientific observation if we don't translate into devices that we can use on patients. And that's the reason why we very close collaborate with university and research center to have this transfer from them, from their research, into a product that we can use on patients.
What role could energy-based regenerative modulation play in chronic musculoskeletal conditions?
Chronic musculoskeletal disease is characterized by widespread low-grade inflammation. And this low-grade inflammation, if it's prolonged, is making the tissue toxic. It means that the cells that are living in this environment do not communicate well between each other, and they are not sending the right signals. So we need to find something that is immunomodulating, modulating the inflammation and reestablishing the cells that are not working anymore with new cells, with our regenerated cells.
What makes QMR technology adaptable across such a different medical specialties while maintaining the same biological philosophy?
Yeah, I would say that the secret of our technology is that we are not solving the solution from the outside, sending a direct message in the inside of our body, but we are just stimulating the body itself to carry on the regeneration. That's, I think, the secret, and has a lot of benefits. For example, we don't need too much effort to be too much invasive, because we have just to trigger some important cells and the regeneration will start. All the process will go automatically. Other two things. One is that we don't fully know the biology. We have now discovered how to modify the genes, the RNA, but we still don't know what happened if we modified one gene, what could be solving one problem, but maybe creating another problem. We don't fully understand the blueprint. And another thing is that our body knows better than us how to heal itself. It has like millions of years of evolution, so they know how to do the job. We just need to stimulate it.
Do you believe the future of the medicine will progressively move towards integrated module of the combining energy and biology and regenerative modulation?
Yeah, absolutely. For example, we can talk about the cell therapies. Cell therapies are acting on the DNA, on the RNA, and sometimes directly on the proteins. We can say that they are acting, let me make this comparison with the hardware of the cell. But we are acting differently with our technology. Using the same comparison, we can say we are acting on the software. This is what we call the electron. Electron is the exchanging, the signals that the cells are exchanging each other. And it's absolutely important to combine multiple therapies in order to target different aspects of the pathology. Because if we have this combination, we can reach much more results compared than a single protocol, a single therapy.
And finally, what is the key scientific message physicians should remember today regarding the role of the QMR technology in modern regenerative medicine?
Leave you with our mission. That is also the driver of our development in the technology and in our devices. That is that we believe in the research. We need the research in order to find the mechanism that are stimulating the regeneration and the healing process of the human body.
Thank you so much, and thank you for your time.
Thank you.